Hi, myself Shiva and I am from Qualcomm. Today I'm going to talk about OpenCLML integration with TVM compiler framework as a BIOC solution. OpenCLML is an extension to the OpenCL specification that accelerates MLOps on Qualcomm platforms. OpenCLML leverages our deep understanding of Adreno to provide highly optimized kernels. This extension follows the standard OpenCL programming model and can be interleaved with other OpenCL kernels by dispatching on the same command queue. OpenCLML support is embedded in the Qualcomm OpenCL driver. The SDK with samples and documentation is available from the Qualcomm Developer Network. Coming to TVM. TVM is Tensor Virtual Machine and is well-known open source compiler framework. It's an Apache project. It basically compiles deep learning models from various frameworks into minimum deployable modules with many different backends. TVM can import models from many frameworks like TensorFlow, PyTorch, Onyx, CoreML, and many more. TVM supports a large range of hardware via many backends like LLVM, OpenCL, CUDA, and many more. TVM has got AutoTVM and AutoSchedule modules, which can generate and tune the kernels very specific to the given hardware and backend. Though TVM does a great job with its kernel tuning mechanisms, there exist a vendor-specific libraries that outperform TVM in many cases at subgraph level. To have the best of both worlds, TVM introduced Bring Your Own Codegen (BYOC) framework to accommodate executing parts of the graph over vendor-specific accelerated paths within a fallback option over TVM. So let's look into what is BYOC and what it does. BYOC allows partitioning the graph for hybrid execution across TVM and vendor-specific accelerated paths. The partitioning can be done based on a listed set of operators or a pattern-based subgraph division. It's a TVM relay module which we use for partitioning. Hence, TVM-based high-level optimizations can be applied before partitioning and also after partitioning over the TVM targeted subgraphs. The subgraphs which are annotated for vendor-specific paths can actually leverage the vendor-specific optimizations as well. Finally, for the codegen, one can extend and use existing JSON codegen or implement an entirely new representation within TVM. That's all about quick intro of TVM's BOC. And while compilation, we generally doesn't require vendor SDK integration as we use generic representation like JSON codegen. For TVM runtime, we need to integrate the SDK with TVM runtime. Here again, we can simplify efforts by reusing JSON runtime, or we can choose to bring a brand new runtime if required. OpenCL backend of TVM is generic and uses standard specification only, whereas Adreno GPU has got proprietary extensions that potentially accelerates kernels. OpenCL offers Adreno GPU accelerated MLOps via an OpenCL extension interface. On the other hand, TVM has got an end-to-end compiler framework with strong front-end support as well as high-level graph optimizations. TVM's VOC allows offloading parts or full graph to execute via vendor-specific library with a fallback option on TVM's default runtimes. With this, and to have the best of both worlds in this work, we aim to integrate OpenCLML into TVM as a BYOC. This effort will have TVM's high-level optimizations along with subgraphs being executed on OpenCLML. Also, the operators that are not supported by OpenCLML will take TVM's default OpenCL paths to make sure we don't fail on supporting an entire network due to a tiny layer unavailable through OpenCLML. With all the efforts and integration into TVM compiler framework, here are some results for MobileNet V1. We built the MobileNet V1 with compatible layers for OpenCLML and to have an entire graph on each path. As seen here, we can greatly improve the performance of the network while offloading parts or full graph to OpenCL accelerated paths. Coming to upstreaming of this feature into TVM community. You can find the RFC under TVM RFC repository, and right now the contribution is in progress. So what's the future work? We have plans to enhance operator and network coverage to let most of the graphs goes through the accelerated path as much as possible. OpenCLML will have newer versions coming up, and we have plans to keep TVM updated with the new releases of OpenCLML. OpenCLML version 2.0 is released recently, and it also supports DNN training too with many backend operators implemented. That concludes my talk. Thank you.